All right, guys, let's talk about the domain of a function. So remember that domain is the set of your input values, which are basically your x values for where the function is defined. So let's go through some different types of functions, and hopefully that will illustrate how you can find the domain. So here you can see we just have in a set of ordered pairs. So this is pretty easy to identify. You know that this is your x value and this is your y coordinate, x coordinate, y coordinate. It's all the way through all of these values here. So all we have to do is just identify the x coordinate, and that's going to be the domain. So for this one, your domain is just going to be -3, -1, 0, 2, and 4. I think most students are familiar with that. Once we get into looking at the actual functions, it gets to be a little bit more difficult. So number 2, f of x is equal to 2x minus 3. So hopefully you recognize that this is a linear function, which means that when you graph it, of course, it's going to look like a line. And roughly, not look like a line, it's going to be a line. And this will look something roughly like this. So it would be impossible to list all the x values like here, because this is a finite set that you have where this is infinite. So what do we want to find? We want to find what x values which makes this function defined. So in other words, what x values can I plug in here and I'm going to get a real y value back? Not an imaginary, it's going to be another real number. So if this goes forever to the left and it's going down, so it's going forever to the left and forever to the right, you can see that no matter what value I plug in for x, I'm going to get a y value back. If I plug in 1, I'm going to get -1 for y. If I plug in 0, I'm going to get -3. I could plug in 1,000,000 for x, and if I plug in 1,000,000 for x, I'm going to get a number. If I plug in -1,000,000, I'm going to get a number. So there is no value of x that we can plug in here where it will not be defined. Every x value is going to be defined. So here our domain is all reals, which we write as -infinity to infinity. All right, let's look at number 3. So here, number 3, you got -2x squared plus 3. Hopefully you recognize that this is a quadratic function, which basically means that when you graph that in there, it's going to be a parabola. So this one is negative, it's up by 3, so it's roughly going to look something like this. Oh, do that, I got stuck there for a second. Roughly something like that. So again, think about what values of x can you plug in here that are going to give you a y value back? Or think of it the other way. Are there any x values that I plug in here where I'm not going to get a real number back? And if you think about it, there's no value of x that I can plug in here where this will not be defined. It's going to be defined everywhere. I could plug in -1,000,000, I could plug in -1,000, I could plug in 0, I could plug in 1, I can plug in 10,000, I can plug in 1,000,000. I'm going to get a y value back no matter what value of x I put in here. So this domain is also all reals, -infinity to infinity. Now this is going to be true for all linear and quadratic functions. You don't even have to do anything else. When you see that you have this linear function here, you know that your domain is going to be all reals, and the same thing if you have a quadratic function. All right, so let's change the function up a little bit. So here we got 1 over x plus 4. So this is rational. This is rational. Well, let's think about where we could have some problems. Remember that if you have a fraction, if you have what value in a denominator will give you a problem. And we would always say if it's 0. So if you have 1 over 0, that is undefined. So that means 0 is a problem for this. Not that 0 is excluded from the domain, it means that this whole denominator cannot equal 0. And that's the key right there with the rational function. When you have a rational function, you take your denominator, set it equal to 0, and whatever you get, you exclude it from the domain. Because when you solve this, whatever you get when you solve this, when you plug that back in here, it's going to equal 0. That's why we're setting it equal to 0. We're trying to say what value of x will make this equal to 0. So when you do that, subtract 4, of course, and you get x is equal to -4. So what that means is when I plug in -4 here, I'm going to get 0 in the denominator, and I cannot have that. Any other value that I plug in for x is okay. I'm going to get a real number back, and I'm not going to get back 0. Any other value is okay, but -4. So for this particular problem, our domain is x is not equal to -4. That means every other value but -4. And in interval notation, -infinity to -4, parentheses, union, -4 to infinity. That's how you exclude one particular value. All right, let's take a look at number 5. So we have the square root function here. So again, let's think about what's going to be a problem. What is going to be a problem with the square root function? What can't we have inside the radical in terms of a square root that will cause a problem? Square root of a negative. If we have the square root of a negative, then that is imaginary, which is not real, of course, and we need the answer to be real. We need our y value to be real. So if we need inside here to be either 0 or some positive number, aren't we saying that we need x minus 4 to be greater than or equal to 0? Isn't that what we're saying? Any other value in here, any other value that's less than 0 is going to make this negative, which will be imaginary. So if I take what's in here and set it greater than or equal to 0, I'm saying I want to find all of the x values that will make inside here either 0 or greater than 0. Of course, when we solve this, we get x is greater than or equal to 4. So that means any value that's greater than or equal to 4 when I plug in here is going to be positive inside the square root. And of course, we could take the square root of a positive and get a real number. You can check it. Plug in 4. 4 minus 4 is 0. The square root of 0 is 0. Plug in 5. 5 minus 4 is 1. Square root of 1 is 1. Now, if you plugged in a number less than 4, you plug in 3. 3 minus 4 is -1. Square root of -1 is I. So it's imaginary. So then our domain is just going to be what we solved here. So our domain is x is greater than or equal to 4, which of course would be a bracket 4 all the way to infinity. Bracket because we're including the 4. All right, and the next one here, we solved polynomial inequalities, and that's going to help us here. And you say, well, how is that going to help? This is a square root. Well, again, we can't have a negative inside here. So we need to figure out what is going to make this negative. What is going to make this negative? So if I go ahead and set this x squared minus 2x minus 8, if I set it greater than or equal to 0, because that's what I want. I want all the values that are going to make it equal to 0 or greater than. Well, we're going to need to take a look at this graphically, which is how we solved the inequalities before. Find your key values. So this is factorable. And then that becomes x equals 4 and x equals -2. Well, again, going over the polynomial inequalities, which I have a separate video on that, that tells us that it's crossing at -2 and it's crossing at 4. And it opens up, so it looks like this, roughly. Now, what do we want? We said we want all the values that are greater than or equal to 0. Well, that's where the graph is above or on the x-axis. Above or on the x-axis, which is what I have highlighted. So we want this interval, that's -infinity, that's +infinity. So we want from -infinity to -2, and then we want from 4 to infinity. That's where it's positive, which will then make this, when we simplify it, it'll make it a real number. So then the domain for this square root function here is simply where the graph is above or on the x-axis. So the domain for this is going to be negative infinity to negative 2 bracket, because we're including the negative 2, union bracket 4 to infinity. And that is the domain for number 6. So hopefully this helps clarify some questions on domain. I try to give you a good variety of the functions. And then next time we're going to pick up with piecewise functions.